In the DCAT, you'll almost certainly be asked to explain how run length encoding works. So here's a quick review. If you are given an image, you'll be expected to use that for your example. I've got a 10 by 10 black and white image, which means I can represent it uncompressed using 100 bits. The widget tells me that if I compress it, I can get it down to 88 bits, which is a small saving. In your answer, you want to say something along the lines of, run length encoding works by telling us how many white squares we have, followed by how many black squares. For the first row, it's very easy. I've simply got 10 white squares. Thus, instead of representing the first row using 10 bits, I can represent it using 2 bits. For the second row, I've got 1 white square, 8 black squares, and 1 white square, which means that instead of using 10 bits for that row, I can do it in 5 bits because I have to use the commas so that we can see how to separate the numbers. When we get down to row 4, things are a little bit dicey because I've got 1 white, 1 black, 1 white, 1 black, 2 white, 1 black, 1 white, 1 black, 1 white. With all this chopping and changing, I end up having to represent that row using more than 10 bits. A full answer explaining run length encoding would look very similar to what you see on your screen. You need to explain that we represent the bits first by saying how many white, then by how many black, separated by commas. You could point out that this method isn't used much in the real world, but it is easy to show how we can change how we represent something and hopefully use fewer bits. Note that on this slide, I've talked about the first 3 rows and shown how I can represent them. The first row would be represented as 10 because it's 10 white squares. The second row would be represented as 0, 10 because I've got no white squares followed by 10 black squares. And then the third row is once again represented as 10. This means that to represent all 3 of those rows, I only need 8 bits instead of the 30 bits I need in the uncompressed form. In a DCAT, you want to discuss rows where you represent using fewer bits, and hopefully you'll have an example like row 4 and 7 where we represent using more bits, and in this case, the compression actually makes things worse. If possible, you should try and discuss the overall compression. So in the case of this image, even though rows 4 and 7 make things worse, at the end, I can represent it with 96 bits instead of 100. It's not much of a compression, but it doesn't make it worse overall. Remember that your best case scenario is a plain white canvas, where in this case we'd be able to represent the entire thing using only 20 bits instead of the 100 bits we need uncompressed.